In this presentation, I'm going to introduce you how to run some basic bivariate correlations using SPSS. First of all, we will review the Pearson product moment correlation coefficient. So just as a reminder, the Pearson correlation should be chosen as a test for continuous variables that are measured on interval scales. However, one of those variables can be categorical if there's just two categories. So you can look at, for instance, what is the relationship between gender and math test performance? Let's check that out using our data set. Okay, here we are in our main SPSS view from our variable view. So just to get to correlations, you just go to Analyze, Correlate, and again, we're doing bivariate correlations in this presentation. We're not going to try to sort of separate out the influence of third variables quite yet. We'll get to that in regression. So bivariate correlation pulls up this dialog box. And so, of course, pretty easy here. Let's choose math test score as well as our gender variable. As you can see here, you can choose the type of correlation test you want SPSS to run. Again, we're going to use the Pearson product moment because math test score is continuous and our gender variable is just categorical with two categories. So one of the things too, you can choose whether or not you want your significance tests to be one or two-tailed. Just to remind you, one-tailed tests are for directional hypotheses. So if you're assuming that you know the direction of the relationship, and two-tailed is for not if you have no hypothesis about the direction of the relationship. So here we have no sort of pre-existing idea about whether or not there's a specific directional relationship between math test score and gender, so we're just going to leave it at two-tailed. And it's nice, SPSS will default, in addition to giving you the p-value, it will give you little stars for statistically significant correlations if you ask it to. And so I'm going to keep that option here. All right, if you go to the actual options boxes, you can also ask SPSS to give you both means and standard deviations as well as the covariances for your relationships if you want. I'm not going to ask for this here. In terms of two as well, SPSS, just like most of sort of the analyses it runs, will give you the option to exclude cases that are missing. So if we exclude cases list-wise, that essentially means that if a case has a missing value for any variable, they're excluded for the entire analysis. So usually I usually go with pairwise because that maintains the sort of overall integrity of our data set. If just because somebody skipped one question, it doesn't mean that they're completely out of the analysis. So usually I stick with pairwise. And that's pretty much it. We're going to stick with our 95% confidence interval as our standard, but we could change that up if we wanted, but we'll just continue on here, and then let's hit OK, and SPSS will run our test. Okay, here we go. So how to interpret this output here. So underneath each correlation coefficient, which is right here, negative 0.022, and negative 0.022 here. So that's the actual coefficient. And then here's the n, the sample size on which that correlation is based. As you know, like kind of our overall data set has 1,000 cases, but again, because of missing information on these two variables, the actual analytic sample is 985 cases. So as we can see here, in terms of the relationship, well, there's a slightly negative relationship between gender and math test score. It's not statistically significant in terms of the p-value is 0.48. So we would not be able to reject the null hypothesis, and we would not be able to say that there's a statistically significant relationship in our population between gender and math test score. Okay, what about English test score? So we would go back up to our correlation dialog box, and where's here? Let's look at gender, and let's look at both English and math. Actually, so another thing I'll point out is you can put multiple sets of variables here, but the important thing is, of course, SPSS is only going to look at the bidirectional relationships between two variables. So as you can see here, here's our output, looking at the correlations among gender, English test score, and math test score. However, this is important because we just did bivariate correlations. It's not, this analysis is not accounting for or controlling for the potential interrelationship between math test score, and English test score when it's looking at the relationship between gender and English test score, etc. So, but let's see here. Oh, okay. So we see here that, first of all, let's interpret these boxes. So first, we already ran in our previous analysis the correlation between gender and math, and here we go again. We see it's still not statistically significant, so that's good because we didn't change anything in our analysis. But here we can look at, oh, there is, in fact, a statistically significant relationship at least a 95% confidence interval, or the p-value is 0.03, that there's a positive relationship between gender and English test score. So what exactly does that mean? Because we need to now to look back at, remind ourselves, how did we measure gender? Oh, okay, so male was 1 and female is 2. That means as because the correlation is positive and female is the higher value that we assigned gender to, let's go back to our output, that means that in general, females had higher test scores than males. So there's a relationship, a positive relationship, and because female was coded as the higher value, that means in our data set, at least there's, it's a weak correlation, a value of only 0.07, right? Because as we know, the coefficient can range from -1 to 1. So this is a pretty weak relationship, but it is statistically significant. And we would say that, again, gender is correlated, or sex is correlated with English test score we're a confidence level of 95% that relationship exists in our population. One thing I forgot to point out, even though our research question was about whether or not there was a relationship between gender and test scores, also because, again, these are all just bivariate correlations. So as you can see in the English and math test score columns, SPSS also calculated the correlation between those two measures, right? So it's -0.04, and it's not statistically significant. As you can see here, the way that the test results are set up is that because, again, these are all bivariate, SPSS produces the results for each relationship. And so you'll see redundancy in the table because, we didn't tell it to restrict the output at all, and you don't really need to do that. But that's why you'll see there's duplicates, right, of the results based on, the fact that there are multiple variables in this analysis, and it will give you the results in both places. So no relationship between math test score and English test score, nor between sex and math test score, but we do see a statistically significant one related to English test score and sex. So how would we report those results in our paper? I will show you. Okay, so in general, what you need to write in your analysis or in your results is the actual correlation coefficient itself, the significance, as well as you want to report the degrees of freedom. So degrees of freedom, and you'll recall I pointed out the N in the table, that's essentially the sample size minus 2, right? Because we're using 2 variables in our correlation. All right, so here, let's say our research question was, what's the relationship between gender and test performance? So I would say I ran a series of bivariate correlations to look at that relationship. Oops, I forgot a period here, but there's not a statistically significant relationship between gender and math test performance for Ethiopian students. And here's, again, our R, it represents correlation. Here's our degrees of freedom. Again, it's N minus 2. And then here is what the actual coefficient was, and then I also put in the p-value. But, of course, we can also say gender is significantly correlated with English test performance, which we tell our readers what that means because, they don't know how we coded gender. So you need to say, indicating that females tended to have higher test scores than males, and then reporting those results. I'll note, for correlations where you're looking at categorical variables with just 2 categories, essentially, this is the same results as you would find with a t-test because, again, we have, just 2 categories. But, depending on your analysis, you might choose to run correlations, oftentimes, again, if your next step will be to do a regression, that would be your next step. But, or this would be your first step would be to look at the correlations. But I do want to point that out is you would find the same statistically significant results if you ran an independent samples t-test between English and our gender variable. Okay, so when our data violate parametric assumptions like not being on a continuous or interval scale or not having a normal distribution or not having a linear relationship, we must use non-parametric tests. There are two types of correlations that are non-parametric that are typically used. The first one is Spearman sometimes called Rho, the Spearman-Rho, or there's also the Kendall's tau, which usually Kendall's tau is better if you have a really small data set with a large number with variables that have a large number of different options, right? Ordinal options, but usually in terms of when I'm running my analyses on my data sets, which have a lot of Likert scaled items, I use the Spearman-Rho. And so to demonstrate, here's a research question we could answer with the Spearman-Rho test. So what is the relationship between students' class year and satisfaction with digital learning? All right, here's our variable view. So we can, first of all, let's double check our variables that we're going to use in our analysis. Class year, first of all, okay. Class year indeed is an ordinal variable, right? It's measured on an ordinal scale. First year is different from and also lower than second year of progressing to third to fourth. Okay, so that's ordinal. Where's satisfaction with digital learning? Here it is. And yes, also ordinal. So 1 represents very dissatisfied, which is definitely lower than the rest of the response options. I want to note, though, that again, you have to have an ordinal variable or just dichotomous. So, for example, preferred mode of learning, digital, traditional, both, there's not an order. There are 3 response options here, but there's not an order to those. So if you wanted to run a correlation looking at preferred mode of learning, you'd need to recode this into 2 other variables or 3 other variables that looks at digital, students who prefer digital, and then recode and combine traditional and both in the same one, and then create another variable that just represents traditional and then compared to the rest of the students, and then both compared to the rest of the students. Because by itself, you wouldn't be able to interpret whatever the results are in terms of the direction of the correlation, because there is no direction, digital to traditional to both. I don't know. I mean, that's kind of, there is no real order. So again, you must use ordinal variables with ordinal scales or dichotomous. Okay, back to this. All right, so in terms of how we actually run our correlate, and again, we're doing a bivariate correlation. Let's clear this all out. So we want to do a Spearman correlation. So it will actually, SPSS will run all of the different correlation coefficients at the same time. But my advice is you are, again, the expert, you're the researcher, and you know your data. And so you should choose the test that's most appropriate for your analysis. Okay, so we're going to do a Spearman with students' class year and correlated with satisfaction with digital learning. Okay, similar to with the Pearson test, you can choose different approach to your missing value. It's not going to give us the option to choose means and standard deviations here, because the idea is that it's running these items on ordinal variables, and these analyses on ordinal variables, and so the means aren't quite as meaningful, right, in the standard deviations. Anyways, okay, so let's see what our results are. Oops. All right, so we can see here right away that there is not a statistically significant relationship between class year and satisfaction with digital learning. Although there's like super weak negative relationship in our data set, right? So that would say within our sample, it seems as though as students progressed in their education, their satisfaction with digital learning decreased. But it's so tiny here that it's not generalizable to the population, and it's not a statistically significant relationship, right? So we would report back that there is no statistically significant relationship between class year and satisfaction with digital learning. Okay, so more precisely, we would report our results like this. It's pretty much the same as how we reported our results for the Pearson correlation. However, one tiny but important difference is you can see here that with, R represents correlation, and correlation coefficient for both Pearson and Spearman. But when you do a Spearman test, not Pearson, Spearman's, I'm getting confused between my two guys. But you put a little S subscript here. So just an R would represent a Pearson correlation results, but if you put a little subscript of an S here, that would be indicate to your readers that this is a Spearman rank correlation coefficient. Separately, if you were actually running a tau, Kendall's tau test, you would use the little Latin symbol for tau, which is a little sort of cursive T, and that would show your readers that you used Kendall's tau instead of Spearman or Pearson. But again, just an R would be Pearson correlation, and then when you're reporting your results of a Spearman rank correlation, you would use the superscript of an S. And so that's basically it. Running correlations is pretty quick and simple in SPSS.